The ideas and content expressed on this podcast are our own and do not reflect the views or opinions of any current or previous employers.
You know, I think you're getting really good at that.
I am. I'm practicing.
Yeah, what we're like 12, 13 deep, and you nailed it. I'm just going to record that and use that for the rest of them so you don't mess them up going
That sounds
forward.
like a fantastic idea. If you could figure out how to edit anything, we wouldn't have to do half of this stuff.
Do that. All right, excuse me. Welcome to Construction Manager Podcast, episode...
I don't know, season 2, episode 3.
Episode 2.
3? We don't know.
Jesus, we are terrible.
Y'all just stick around and listen to
Anyway, so today we've got Matthew Cooper with us, which is awesome. He is with PEG, which I believe, Matthew, correct me if I'm wrong, but that stands for Patuxent Environmental Group?
Originally, yes, when the company started 21 years ago, but these days it's just PEG LLC.
I love it.
PEG LLC.
I love it. So we're actually going to talk. So we told all of our wonderful listeners that we were going to get a little more technical this season, which we are, and we're going to talk about something today that is near and dear to my heart, which is building science. Excuse me, which I feel is like the missing link in construction management training. You know, most companies spend their dollars training their construction managers or superintendents how to use scheduling software, you know, the ins and outs of concrete, roofing, flashing. So they spend their money kind of in an overall, like, these are the different pieces that go into this structure, but they never really talk about how that structure works, how the systems integrate together, how the thermal envelope works with the HVAC, and how all the different pieces go together, which is one of the reasons we brought Matthew on, is because he is an expert in the field of building science, has an amazing track record in it, and I think can really talk to us about the need and the necessity for that missing piece to be integrated into our construction management training. So without getting too much into that, Matt, can you just tell us a little bit about yourself and your company while I clear my throat?
Yeah, absolutely. I appreciate you guys having me on. This is an exciting opportunity to talk about building science and residential new construction. Like you said, I think it's an area that's strongly overlooked, and it really is a very important area, particularly when it comes to the quality of construction and ultimately the livability or the comfort of, and even in some cases the health of a home that is a major investment for a lot of people. So we do feel it's really important. As I said earlier, our company's in its 21st year in business. We're an engineering and energy-focused consulting firm. We're licensed mechanical engineers in all 50 states, and we work daily, conduct about 4,000 inspections of residential new construction every day across about 26 states.
That is amazing.
Wow.
And thank you. And we've been the Energy Star Partner of the Year as an energy rater for the last 8 years in a row.
Yeah, that's incredible. Actually, I follow that. Every time I see it, I see you guys out there, I'm like, man, look at them. They are killing it. So that is super impressive. And, you know, full disclosure, I've had a chance to work directly with PEG, and I'm telling you, it's a great organization.
Say, you worked in this industry, right?
I did. I worked in this industry a few years ago, and PEG is definitely the leader in, you know, home energy and building science. They, I will say, it's a group of professionals, and it was a pleasure working with them, you know, briefly a few years ago. Anyway, so let's get into this. So let me back up a little bit. So, it's lost my train of thought. It's so rare that I give compliments. I don't know what to do afterwards.
All right, so the first topic on the list was just building science in general and what the definition is. And I was just joking with Damien a second ago. I said, when I read this podcast, it sounds like this definition was something that Damien made up when he was writing this outline.
It's to make us sound more lofty, man. More scholastic.
Go ahead and read it.
So basically, building science, right? It's the knowledge that focuses on the analysis of the physical phenomenon affecting buildings. Like an easy way to say that is essentially it's how weather and environment affect the functionality of a building or how a building works. Matthew, would you agree with that?
Yeah, I mean, when we talk about building science, you know, to talk about it in its simplest form, it's how do we get the high performance buildings, residential new construction homes of today to function in the manner that they were intended to function, and to be able to provide the comfort and moisture control, et cetera, that buyers expect and deserve.
Yeah. So, and moisture control, I will tell you, is probably the hottest topic in the construction industry from a builder's standpoint that I can.
You mean in Virginia when it rains every single day for like 2 straight years?
Right. I mean,
Exactly.
it's huge. We spend a lot of time talking about moisture control and really how to keep moisture out. But what we don't talk about is moisture migration, which is part of building science, or really thermodynamics, which is essentially how heat moves. So I'm going to get lofty again with Jason here.
That's the second thing on the list. Yeah.
So thermodynamics is a branch of physics that deals with the relationships between heat and other forms of energy. So essentially, hot goes to cold. If you can remember that, then you're good. And the same thing with moisture. I mean, we have spent so much time and energy trying to figure out how to keep moisture out of our homes and buildings that but one thing I don't ever remember talking about is how moisture moves, whether it's through air. So that's a big one. So let's kind of talk about the thermal envelope if we can, because you've got your roof system, your wall system, your exterior walls, so whether it's your sheathing, and then you've got Tyvek or you've got zip wall or whatever you use on the outside of your building. Then you've got your cladding, and that whole system works together, and everybody focuses on moisture, right? Because it's so important. But the one thing that I find that kind of gets missed a lot is the air infiltration, because people don't realize that moisture will travel through air. So if you have like a leaky building, all that moisture is coming right in. So I give you an example.
You mean if it's not airtight?
If it's not airtight. But and Matthew, this is something that I've struggled with for years. We build these buildings so airtight that all of a sudden we have to introduce mechanical ventilation. So I'm like, maybe we don't build them so airtight and we don't need that mechanical ventilation. And I go back and forth with that. Go ahead.
Yeah, I mean, for decades and decades of new home construction in the U.S., there was not an emphasis on airtightness from a perspective of controlling utility costs for heating and cooling. But definitely since 2006, the energy codes since 2006 onward have made huge steps in the requirements for how the thermal envelope performs. And even though codes are adopted in different phases at different points across the country, and we have to take into consideration that every climate zone comes with its own requirements. So if you're building a house in Santa Fe, New Mexico, it's very different than building a house in Buffalo, New York, or building a house in Raleigh, North Carolina. And when as you said, when you talk about thermal dynamics, for me, the simplest way to envision what you're talking about is that energy in any form always tries to reach equilibrium. So energy of anywhere there's a higher concentration of energy on one side of a physical structure to a lower concentration of energy on the other, they're going to try to equalize. And that really drives how we design and build the exterior envelope of our homes. Is what's the predominant condition for that part of the U.S. For the majority of the year. So that's why we have very different strategies for exterior envelope and where air barriers go, where vapor barriers go, where insulation goes, depending on are you a predominantly cooling climate or a predominantly heating climate, or like you said in Virginia, you're a mixed humid climate. And sometimes it's not so mixed. It's just humid constantly, and that really is the beginning force of how do we understand what's moving and how is it moving. It's always going to move from the higher concentration to the lower concentration, trying to reach equilibrium. And we build these wonderful boxes and try to break up that process of physics.
Yeah. You know, it's funny you say that because we get a lot of requests for some crazy stuff. So we're talking about, if I can just digress a little bit, so we talk about insulation a little bit. We are constantly getting requests. People say, you know what, I want insulation in every single interior wall in my house. And, you know, I ask them, I say, why would you want to do that? And they say, well, for sound. I'm like, but, that's when I go into my whole, you know, this house is designed to have a thermal envelope, and that insulation goes on the exterior walls, just like you're saying, to keep the cold out or the hot out, so that we can make that interior comfortable. And when we start insulating all the interior walls, we're actually like turning that thermal envelope into just a maze, a mess, and the house we're building or whatever it happens to be just isn't able to heat and cool the way the house was designed to if you start changing the boundary levels.
Sectioning off parts of the house.
You know, let's talk about that because that's one thing. It's really important to recognize as a construction manager or a superintendent or anyone really. You need to know how to identify your thermal envelope. Where is it? So before you even start the construction of a building, you need to open up the plans and look at it and say, what is this space used for? So if you look at, I'll use attic space as an example. You know, depending on the structure you're building, most houses, that attic space is unconditioned space and might as well be outside. So your thermal envelope is actually the ceiling of your top floor, not the roof line. And it's important to understand that, you know, your moisture plane, it will be the roof line.
Right.
But your thermal envelope actually falls below that on that ceiling.
You know, and to take it back down to like the construction manager's level, where you're going to have this discussion is with a homeowner.
For sure.
And, you know, I was always taught to say, wherever you're standing in a finished space in your home, all of the walls should be insulated where you're standing. Above your head, on the sides, not necessarily below you.
Yeah.
And that's the rule of thumb. And like you said, when you start cordoning off parts of the house with insulation, it makes it heat and cool differently.
It does.
Matthew, have you seen issues where certain parts were insulated in a home and it's caused an issue?
Well, the interesting thing about, you know, the envelope, the acceleration of how well homes perform today, there's so many, you know, better performing products available today, from house wraps to zip panels to all kinds of solutions that are out there. And really what's happened is that since the overall performance of the envelope of most homes has gotten much better, where there's a fault in that envelope becomes a point of concentration. And that's what we see more than anything today is that, you know, we may have, you know, fantastic windows. We have a fantastic, you know, basic envelope from a thermal performance perspective. But if we miss something like bandboard insulation or air sealing at the bandboard, now where air is able to get in, it's going to come in at a much higher rate than it would have if the entire envelope was leaky. And that's really what happened. You know, our homes, when they were being built in the 40s, 50s, 60s, and even in the 70s, you know, air could get in wherever it wanted to. And so it didn't concentrate. But now, since the envelopes perform so well, where it gets in at a high rate, and it brings moisture with it, brings temperature with it, and that's where we end up with, you know, in a lot of parts of the country, we have sweating ducts where, you know, we run a bulkhead around the perimeter of a room, and the ductwork is inside that bulkhead, and maybe, you know, nobody remembered to insulate on the back side of where that chase is or where that bulkhead is. So that's where the most air gets in, and it comes right into contact with the ductwork, which is either hot or cold, and that causes duct sweating. So we've kind of created a little bit of a monster ourselves by having all these awesome products to use, because if they don't get used properly, like you said, the first step for, you know, any construction professional is read the drawings, look at the plans, understand the manufacturer's installation guidelines for those products, and really you also have to understand and analyze the scope of work or the phase spec for your trades. Yeah. And understand who's responsible for that air sealing, who's responsible for that air barrier, and make sure that they're there, because it really gravitates towards a much smaller area and drives with much harder force. Because when we talked about the thermodynamics earlier in the conversation, it hasn't gotten any cooler outside in the summertime. It hasn't gotten any warmer outside in the wintertime. But now that difference that's trying to equalize, it has a much smaller area to try and do it.
Yeah.
So you're basically saying if you have a very tight home with one void, it will exchange cold air, let's say, in the wintertime into your house much faster than much faster than if you had like leaky windows all the way around it. You see a much larger exchange of air.
Yeah, and that's a very common thing when you're walking a new house with a new buyer, or maybe a buyer has just moved in and they're experiencing their first winter, and they call and they say, hey, I feel cold air coming in through this exterior wall electrical outlet. I thought you said my home was an energy efficient home, and maybe the blower door numbers for testing the air infiltration of the house are fantastic. They meet every standard, but where the air is getting in, it's going to come in through the path of least resistance, and often it's something as simple as an exterior wall electrical socket and the outlet, and the homeowner feels it, and suddenly they question in their mind, is my house really energy efficient?
Right. When
it's a very small amount of air, but it's very noticeable.
I used to get that all the time. The other issue I used to hear a lot was, especially with new construction, people would have set their dining rooms up. They'd have lots of windows and stuff, and the same. So there's this occurrence called convective currents, right? So that's when hot meets cold, and you get this airflow, right? One goes up, one goes down. Essentially, you get a current.
You're feeling it.
And people will sit next to a window in their dining room like, these windows are so leaky. These windows are so leaky. And one of the things I used to do is I would set up a blower door, which is essentially, what's the best way to describe that, Matthew? It's a big. It's used to either pressurize or
depressurize.
Depressurize? Is that the word?
Yeah, it's a calibrated fan. It's a calibrated fan that's used to simulate a pressure difference across the envelope of the house.
Okay, perfect. So what happens is, essentially, if you're sucking all the air out of the house, what it's going to do is draw outdoor air into the house,
and you'll show you where it is.
And show you where it is. You can use a thermal camera. You can use smoke pen. You can just use your hand. So I would set this up, and what I found a lot of times, especially with cheap windows, you would get, if it's really cold outside and it's hot inside, you get this current on the surface of the glass. And it's enough to move the hair on your arm. So people would be like, these windows are so leaky, are so leaky. So I'd set this blower door up, go over, and I'd show them it's not your windows that are leaking. You just have cheap ass windows.
They're not leaking. They just don't insulate very
well. Right. So anyway, but when you set these blower doors up, it can be dramatic, the air infiltration, because really it exaggerates the stack effect. Correct if I'm saying anything that's wrong. I've been out of it for a little bit, Matthew, but just feel free to jump in and correct me. But it exaggerates the stack effect of a house or a structure, right? Which basically means, Matthew was talking about that equilibrium, right? So you get, and you hear this a lot in multi-story homes, townhomes specifically, condo buildings, things like that, where you get, it's always colder on the ground floor, hotter on the top floor because heat rises, and because we've got this phenomenon where hot always goes to cold, so you get this air that comes in low and it goes up high, and it accumulates up there. When you're walking up a flight of stairs in like a 3 or 4 story building, you can actually feel that equilibrium point as you walk through it in most houses. But that blower door, and one of the things it does is it exaggerates that effect in a house.
Yeah. Well, I mean, we're also digging a hole and building the first floor of the house underground, essentially.
Yeah.
So that's naturally going to be cooler in the winter, or cooler. It's going to be cooler all the time, right? How Matthew? How do you see correction of issues when you hear the age-old "my basement is cold and my attic is hot"?
Well, we look at a kind of a simple explanation. Is in any structure you have planned airflow, and you may have unplanned airflow, and here again, when we've built a really awesome performing envelope, in a lot of cases, our HVAC systems design and selection are not keeping up to speed with the envelope performance and the way that we're building homes. A lot of builders are panelized, or they're completely off-site built, or they're using advanced framing that really allows for quality insulation all the way into corners of a home, called a California corner. So we've got really well-performing envelopes, and in a lot of cases, unfortunately, the HVAC industry hasn't caught up. And, we're still doing things like putting registers out at the perimeter to wash windows, when today's windows don't need to be washed because they have excellent UV performance. When we have unplanned airflow, often it can be because, some parts of the country like to use centralized returns with jump ducts or undercut doors or transfer grills. Other places in the country, the contractors, they're typically going to run a return to every room. We try to focus on a kind of a combined strategy where we've got some traditional installation guidelines with some what we call compact design, where we're using better quality registers that actually mix air in the room, and we do a combination of centralized return with ducted return to a master suite. And often, that highest room or that highest part of the house tends to be where we often put things like the master suite. And you've got the people that have invested the most into this house that have the least amount of comfort. And really, that comes down to how well was the HVAC system designed, and was it sized properly so that there was enough velocity in the ductwork when it gets to that furthest point of supply that it's able to mix air in the room, or was it not designed that well and you've got great air exchange on lower floors and very little left to treat the upper floors. So those things combined with stack effect. When we build tall skinnies, we build 4-story towns, what have you. It can manifest itself into a really challenging thing to try to figure out what exactly is wrong and how do I fix it.
So I am going to now refer to every single townhouse as a tall skinny.
Tall skinnies, I love
it. It's funny, and I will tell you, Matt, I think it's through the EPA and all the information, BPI, ResNet, all these organizations that are out there, and they're educating people about building science. I'll give you a great example. You were talking about comfort. One complaint that I've heard for years, and I don't actually hear it anymore because most builders have caught on and fixed this problem, but people would always say, we always like to put that master suite above the garage, or there's a nursery above the garage. And people are, traditionally like, oh, it's so cold in this room. And traditionally I would always say, well, yeah, you've got 1, 2, 3, 4, 5 exterior walls in this room. It's going to be colder. But through, education on insulation and air sealing and HVAC design, you're finding that now the ceilings of those garages we're using products like spray foam, which does both insulate and air seal at the same time. Right. And it really, you take that and you combine that with a better HVAC design, and all of a sudden those rooms are as comfortable as the rest of the rooms.
And most of the time when you have that complaint, the air seal is the issue.
For sure.
Because it's always insulated.
Yep.
It's insulated. That's inspected. But the small areas that were missed is usually what causes the problem.
I'll tell you, air sealing can cause lack of air sealing and airflow can cause just horrible problems. I've heard of builders that have had to, rip out the top floor of, multiple townhomes, tall skinnies, because of condensation collecting in the attic because there's not enough ventilation in like a flat roof. And you get that condensation and it literally turns that ceiling to mush.
Yeah.
And, mold starts to form and all kinds of problems. So that's, it's so critical. So I would really recommend any superintendent or construction manager out there that wants to really take their knowledge to the next level, look into building science. Go to ResNet's website, go to BPI, which is the Building Performance Institute's website. There's tons of information out there. Crack a book and or just listen to this podcast over and over again until you got it. But really, once you start to understand thermodynamics and stack effect and how buildings work as a system, it will take your knowledge and your game as a manager of construction projects to the next level.
And hopefully it helps when you're doing those checks along the process, thinking about these things while you're looking at the house, while it's time to check HVAC and weather seal and air seal and insulation before you start closing it up and experiencing the problems later.
I would also say if you've got an issue with a building, it is important to have a company like PEG on speed dial so that if you've got ductwork issue, like your ducts are condensating and things like that, you can call an expert. If you can't figure it out yourself, call an expert. Have them come out, give a second opinion, take a look at it, set up a blower door, do some thermal imaging, see if you can identify the problem before it becomes a big deal. So anyway, Matt, we got to wrap it up a little bit, but I'm telling you, it was fantastic having you on. I think that Jason and I have dumbed you down a little bit, and you have made us smarter.
A lot of it. Matthew, where can people find you if they do want to get a testing done or anything?
Yeah, absolutely. So, our website is www.pegenv.com. You can also find us on Twitter and Facebook and LinkedIn. We have a lot of folks in our organization that are very, very involved in speaking and presenting, and we do a lot of training with builders where we come out and we work with trades and we educate them on why the simplest things are really so important, and that's where not everybody needs to be a building science geek. It's really just attention to detail, and it's simple things like flashing and lapping and air sealing and quality of installation install, and it can make a world of difference in the products that are being put out there.
Amen. I love it. Awesome. All right, guys, that is going to be a wrap for whichever episode in season 2 this is. Jason and I can't decide. Please keep listening. Follow us on LinkedIn. Follow us? Yeah, follow us on LinkedIn. Check out the website, constructionmanagement.com. We still have some exciting news coming. We're trying to plan a live event, which will be amazing. We'll have details probably on Instagram first, and we'll put it out to the world in the next podcast or so. We don't make any promises. We're not the best.
Thanks again to Matthew. We really appreciate you coming on.
Awesome. All right, guys. Thanks so much.
Thanks, guys.
All right, Matt. Thank you.